Hi everyone. I wanted to share a walkthrough of the code for the CleanStream OBS plugin that I had created. This plugin cleans live audio streams from unwanted words or utterances like filler words, like as well as profanities, as you may encounter those in your live streams. Um, the plugin is built in C++, and I wanted to share a little code walkthrough just to kind of how the plugin is built. I think I cracked a few interesting things here, so you may learn from that. And it will also just give you an introduction into kind of how it works and how it looks like. All right, so this plugin is an audio plugin. An audio filter. So this means that in the plugin definition, in the main plugin file, we would have source audio in type filter. So this gives us one function, basically one entry point in which we're going to get the audio frames. They're going to come in here. The audio data is going to come in here, and we can do our processing here, return audio data on this one, and that will render the audio back to the to OBS. So this is where everything basically happens in this one function here. But there's a few things going on here except for that, like the properties and updating those, creating and destroying. There's a lot of things going on there. But let's get to the meat of the plugin here in the filter audio. All right, so this plugin is built on top of Whisper C++. Whisper C++ is a project by G. Gerganov, and I highly recommend going and checking this out at Whisper CPP on GitHub. It's an excellent project that basically builds the OpenAI Whisper speech recognition model from the ground up in C++ without any dependencies, which is very cool. Then we can very easily bring this into OBS. There's virtually two source files and two header files, Whisper CPP H and then ggmlc and H. This is the only thing you would need to run Whisper inside any other C++ program, as long as you can bring those in. And this is what I did. I brought it in here, and inside my filter audio function, I'm basically calling Whisper CPP to transcribe the audio. But there's a few things here going on since this is running the neural network for Whisper is pretty slow. I needed to do that in a different thread. So that it could continuously run in the background. And that required me to do a couple of things in buffering and threading. So what I have here in my filter audio input function, I'm getting the audio data here. These are frames of audio inside a sample. It's about 10 milliseconds as it comes in, 10 milliseconds of data. And at 48 kilohertz, that translates to a few thousand, a couple thousand audio frames in floating point. So this is what we're getting here on audio, on OBS audio data. We have here a data buffer that is essentially just an unsigned. It's like bytes of data, but really what they are floating point numbers that give you basically the audio frames at the sample rate that is for incoming for this audio source. So what I'm taking here is I'm taking the data and I'm putting it inside a circular buffer. So this function here will only be pushing this incoming data into this buffer. The other thread that's running Whisper will pull from this buffer and clean it up as it goes along, and this would be pushing. So I have a buffer here that has two parts. One is just the actual raw data, the floating point numbers here from the data that we're getting in here, and the second is an info buffer. This trick I learned from one of the OBS plugins that does audio processing. Is whenever I push data into this buffer, I have a second buffer that only says how many frames, so how many floating point numbers, basically how many audio frames are in this data buffer, and what is the timestamp. This is going to be very important later when we want to stitch together the audio coming back from the Whisper processing back into here. We would need to know exactly the timestamps, or else everything's going to go out of tune. So I have two buffers here, the input buffer and the info buffer. So I'm pushing data and then info into these two buffers. Now the other thread's going to take care of like pulling this from here in the circular buffer. So I'm always pushing at the back and popping in the front. So we'll get to that. The other part in this filter audio obviously would be taking the input data and then outputting things that Whisper has finished processing. And this is basically the second part here. I have another two buffers, an info buffer and a data buffer. So here I'm pushing in the back, but here I'm popping in the front because the other thread is going to be pushing into data into these two buffers all the time, and I'm cleaning them up here in the audio rendering. So again, some blocking, a lock guard mutex just to make sure that the other thread is not currently pushing data into here. Then if it's not, I'm clearing out some information from this buffer, logging and so on, and then returning that for OBS as the data to be played to the user. All right, so this is one part here. Just the main part of the plugin is pushing data for processing and then pulling data from the background processor to run in here. Okay. So let's have a look at create and see exactly what happens and what are the different parts of this plugin. So when a plugin comes up, I have to get those buffers up in initialized, in some memory allocated and so on, just for moving stuff here and there. The other part is to initialize Whisper. So the Whisper context, this is basically running the Whisper CPP and picking up the tiny Whisper model and loading that into the plugin. So when the plugin comes up, it's going to load that file and get the context up and running. So we have that. The second part is the Whisper params. There's a bunch of parameters. We'll get to that in a moment. And the rest of the things here that we're using are also quite necessary. I'm using this overlap region. I'll talk to that in a second. So we have to initialize that overlap between different samples coming in. And the other part is conversion. Since the source in OBS is using 48 kilohertz and Whisper runs at 16 kilohertz, we need a resampler. So OBS gives us this resampler mechanism here that we can essentially just use. So I have two of them going from destination to source and then source to destination, although I'm not really using this one. I'm going source to destination. So taking the sample rate that I have from the audio source, which I figure out in here, audio output get sample rate from this current audio, the sample rate and the channels, obviously. I can also calculate the number of frames inside one buffer size. I set the buffer size to be a second and 10 milliseconds or 1010 milliseconds because Whisper can only run, Whisper CPP can only run on 1 second and above. So I set it just 10 milliseconds above that. That will be the size of my frame. that I'm passing on to Whisper every time. I also have this overlap region. All right, so we get the resampler in place, and then a few other parameters loaded up. The update function here is very simple. All that it does is takes the parameters that I have on the parameters that I have, basically puts them up on inside our transient data, or the shared data model for this plugin. All right, the destroy function is pretty self-explanatory. Check that out. Okay, so once everything is set up and ready to go, let's go ahead and dive into the processing thread. This is a thread that I'm starting up. It's called Whisper Loop. It gets the data for the shared data for the plugin. There's interesting things in there that this thread would need, but all it does continuously is basically grab some information from the buffer. So here I'm seeing that my Whisper context is actually initialized. If it's not, then this thread has nothing to do. The next part is to see if there's actually data to process. So locking the mutex on my buffer, checking out its size. If I have something to process, that's great. If I don't, I just basically sleep and keep going. So this is all that thread is doing, and the actual bulk of the operation happens here in process audio from buffer. Process audio from buffer will clean out some data from the input buffer. So remember that info. I'm picking up an info struct from there. It's in a while loop because remember this is 10 milliseconds, little chunks of audio that I'm basically accumulating into a bigger buffer of about 1 second. So I'm gonna have to cycle through all of those info buffers in the input and collecting all that data and picking all that up until I reach the size of my requested size. So I have a size of a frame is about 1 second, and then I have an overlap region. The overlap region is going to come from the previous section, the previous process section. The overlap frame is actually dynamic. It might be 300 milliseconds, it might be 400, it might be 200. That depends of kind of how long Whisper takes to process things. So what I need from this input buffer is the size of my frame should be 1 second minus the size of the overlap from the last frame, which might be 300. So overall about 700 milliseconds I'm going to have to pull from the data that OBS is queuing on this circular buffer. So I just keep doing that until I hit this limit here and then break and start basically collecting the actual data. So once I figured out how many frames, how many floating point numbers, basically floating point audio samples I have, I need to grab from the data buffer. I start grabbing it from the data buffer. So this is where I'm taking my overlap region from the previous section. Here I'm looking strictly at overlap, at the overlap frames, how many frames of floating point I need to grab from the other section, and I'm copying this to the beginning of my processing buffer. So I'm taking it from the end of the previous buffer, so the copy buffer plus the last number, the last frame minus the overlap frame. So I'm basically taking the last part of my processing buffer and copying it to the beginning of that buffer. And then on top of that beginning, so it will be copy buffer plus the overlap frames, I am bringing in the new data, the new frames from the buffer. So overall, I'm going to have roughly 1 second of information to process. All right. That information comes in at about 48 kilohertz. I'm going to have to resample that. I have the resample for that, and out frames and output would basically be the data in 16 kilohertz. So this is data that's ready for Whisper to start processing. One thing I have here is the VAD. The VAD is basically voice activation. The voice activation just says if this is an empty frame, so there's no audio, nothing there to process. The algorithm is super simple, and that comes from the Whisper CPP example that I took here. It implements a very simple VAD, and this VAD essentially just looks at the energy in all the windows, calculates the average energy, and looks at that average energy and sees if it passes some sort of threshold. So very simple algorithm for VAD. All right, if this audio snippet of about 1 second has actually an actual utterance, something that we would want to process, then I send it through the Whisper algorithm, and this function is very short. All it does is run the Whisper full from Whisper CPP with our parameters, and it sends in the data, the floating point data for the audio, including its size, and getting the result. The result from that is going to be some sort of transcribed, some sort of transcription of the text. Let's get to that in a moment. If I find that this result from here is a filler word, then I null that out. I set 0 to just this part. It's a filler segment, so I'm going to reduce the volume to 0. So I'm doing that here. For all the channels, I basically set all of the buffer to 0 so that it silences out this portion of the audio. If this is a profanity or something we would want to beep, I am adding a beep. So instead of setting to 0, I'm adding a beep at 440 hertz. So basically creating a little sine wave here and adding that into the copy buffer, into the basically the output here. All right, once that is done, I'm pretty much all set here in terms of like the audio that this had produced, and I'm putting this on the output buffer. So again, the info would say how many frames and what's the timestamp, and then the data buffer would have the actual floating point data pushed back on this circular buffer. And that is about it. In here, I am doing some heuristic about the overlap region. So if Whisper took more time to process than the incoming data, let's say we have 700 milliseconds to process, but Whisper took 750 milliseconds, I would want to reduce the overlap region so that we process more new data with a smaller overlap, so that we save up on time a little bit for the next run. So I'm reducing it by 10 milliseconds, my overlap region by 10 milliseconds, and capping that at a minimum of 100. But if the other thing happens, let's say that we process 700 milliseconds of audio, but we only needed 650 milliseconds to process it. So we have a little bit of positive gap, positive delta. So I would like to increase the overlap region. In essence, we would want the overlap range to be as big as possible, but since Whisper is pretty heavy, it has to be, it's kind of like a dynamic sort of setup for the overlap. So we try to keep it as big as possible, as large as possible, but if Whisper doesn't go very fast, then it's going to reduce. The ideal situation would be to have a very big overlap so that we never miss any sort of audio. We always hear it twice. We always give Whisper an opportunity to hear it twice and to figure out what's inside there. All right, so let's have a look again at the Whisper inference and what's going on there. So once I run Whisper on this, I need to process the results from Whisper, and Whisper gives you the results. It's not immediately in text. You actually get it in tokens, and the tokens need to be decoded into text. So Whisper CPP actually has a few interesting things that can make that easy. First would be the get segment text. I'm capping it to just the one segment because these are very, very short snippets of audio. I'm not expecting many sentences to exist here, so just the one sentence. I'm looking at the segment 0, expecting there will be only one. You can get the entire text. That will be a const char pointer that we can process, and the T0, T1, just the timings of that. But I'm also going token by token and getting their probabilities, summing all that up to give us the general sentence probability for all the tokens that came out from there, and that's something that we could use for doing some thresholding and so on. All right, to detect actually the fillers and the profanities, the beeps, I would use regular expression. I'm just using very standard regular expression from C++. This is the detect regex and the beep regex are user defined, and they have some pretty decent defaults that I've found, like these two. And once I have a detection there, I return it back out from here into the processor that will do the actual processing on the audio. All right, so there you have it. This plugin that I wrote based on Whisper CPP. There's a couple of things here that I hope that you can learn from, like using those circular buffers and using multi-threading inside the plugin, using Whisper CPP. All of that is available on my in the GitHub repo. So feel free to check that out. Copy out whatever code you need. Check this out in itself. Download it and try to use it. And also check out the plugin on OBS and try it with your OBS and figure out if it works for you. But hopefully you've learned something from this. Thanks very much, and I'll catch you in the next video.